Hi, everyone. Welcome to trigonometry. We are going to start by thinking about circles. We're very quickly going to move on to the most important topic for trigonometry, which is the unit circle. That gets everything started. But before we get that, we need to actually look at circles with their equations and their graphs. So this is something that we haven't done in the past. In the past, we've only sketched circles, thought about the radius, and these types of things. But we've never really thought about graphing them, for example, on Desmos. So here's your first example. If I enter the equation x minus 3 quantity squared plus y plus 2 quantity squared, and I set it equal to 16, it graphs this beautiful circle right here. All right, so let's observe a couple of the things about it. All right, let's notice. There's two important features for a circle. If you get two features correct for a circle, you will know its exact location. And those two features are the center of the circle and the radius of the circle. If you know the center and the radius of a circle, then you have basically determined all of its features. All right, so here's what I mean. This circle seems to have a center at 3, -2. 3, -2. So let me enter that coordinate. 3, -2. All right. And apparently, because my scale is counting by 1, its radius is 4. So here's a circle with center 3, -2, radius 4. How does that relate to the equation? Well, take a look at this equation. This equation is known to be in standard form. Standard form is very straightforward. All right. So you want to think back of what you've learned about factors and zeros. All right. So your first right here part of this equation contains x minus 3 quantity squared. All right. The second part contains y plus 2 quantity squared. All right. And the last part contains 16. Think about the zeros of those individual pieces, right? If you would think of x minus 3 as a factor, well, the 0 would be 3. And for the second one, for y plus 2, the 0 would be -2. All right. Well, it turns out that 3, -2 is the center of the circle because in standard form, the number that you subtract from x and the number that you subtract from y, in other words, hk, all right, those will represent the center of the circle. So here's the actual standard form, the sort of format for it. X minus h quantity squared plus y minus k quantity squared equals r squared. All right, so hk represents the center. Whatever h is will be your x coordinate. Whatever k is will be your y coordinate for the center. Now, the last thing to understand is r squared. R represents, guess what? The radius. So whatever number you have on the right side of the equation when you're in standard form, that number will represent the radius squared. So 16, for example, 16 is not the radius of the circle. We determined in the very beginning when we saw it that the radius was 4. Therefore, you can think of 16 as 4 squared. All right. If I change that value 16 to any other value, it will also change the radius of the circle. For example, if I change it to 81, well, now I have a circle with a radius of 9 units. Okay. That's because 81 is 9 squared. So again, the number on the right side for a standard form circle represents the radius squared. Okay, and this is really a lot like Pythagorean theorem. All right, you have a quantity squared plus another quantity squared equals a third quantity squared. All right, that's a squared plus b squared equals c squared. And there's a big relationship right there between circles, distance formula, Pythagorean theorem. All right, all of that is meshing together right here to think about examples of circles. All right, so let's end with one last example. All right, so if I have the circle x plus 1 quantity squared plus y minus 3 quantity squared set equal to 9, your job is to be able to predict the location, the exact location and size of that circle. So take a second to think about it. What would its center be? Well, we could predict that the center would be at -1, 3. That's that. Okay. I extracted my h and k values. Then what's the radius? Well, 9 is the radius squared. So I can take the square root of 9 to find radius. In other words, the radius should be 3. All right. So I could plot a couple of extra points. Now when I graph it, my center is correct, my radius is 3, and I have now a full understanding of the standard form of circles.